Welcome back to my channel, Niloy for Physics. In my previous episodes, we have already solved 19 questions of JEE Main. Now we will pick up from question number 20. Okay, let us quickly see. We are still in the chapter of units and dimensions, and we will just proceed with the JEE Mains problems. Question number 20. Question number 20 is to an expression is given where P is a dimensionless quantity. Now, please don't pre-assume the P to be pressure or P to be any other quantity. It is said that P is dimensionless. Moment it is said that P is dimensionless, we must write that P becomes equal to M0, L0, T0 because it is dimensionless. Okay. Now it is given that P is dimensionless and the terms inside, there is a logarithmic term. Now, what is the dimension of a logarithmic term? See, if it is given that log EX should be dimensionless if the argument of X, whatever is there, log EX, if the argument of X is dimensionless, log EX is also dimensionless. Okay. So that makes whatever the term inside the logarithm, that is kt by beta x, should also be dimensionless. So here also I am writing in the form, this also I am writing as M0, L0, T0. Fine. So we have to find out what are the dimensions of alpha. Okay. What is the dimension of alpha? Like if P equal to alpha by beta into logarithmic of something, then alpha by beta should have the same dimension as that of P. If P is dimensionless, so alpha by beta is also dimensionless. So that makes it, we can write that alpha by beta is also dimensionless. That is why it is M0, L0, T0. Fine. Now with kt by beta x equal to M0, L0, T0, from here we can write kt by beta x equal to 1 or beta equal to kt by x. Okay. Now beta equal to kt by x, k is Stephen-Boltzmann constant, it is given. Stephen-Boltzmann constant, we have already derived the dimensions in my earlier episode. So I'm not going to derive it once again because of the want of time. You may refer to my earlier episodes should you wish to. Then you will get to know what is the dimension of x, k. So Stephen-Boltzmann constant. Okay. So k we are writing here, beta, it is m L square T minus 2 K minus 1. Okay, here capital K is for Kelvin, that is for temperature, and there is a T term here. This T term is also temperature, so I am writing K again divided by L. Okay, so this becomes, beta becomes M L T minus 2. Okay, and alpha by beta is equal to P is equal to 1 because it is dimensionless. So alpha becomes equal to beta is equal to MLT minus 2. Fine. So that is the solution of this problem. Okay, next. Next is the dimension of mutual inductance. We have to find out what is the dimension of mutual inductance. Mutual inductance comes in the chapter of electromagnetic induction. Those who are in class 11 may not have proper idea of this, but it will be covered in class 12 physics. Okay, mutual inductance. So it will be there in the chapter of electromagnetic induction. So we have to find out the dimension. So how to find out? We can write that M, that is mutual induction. It is, or we can write it down like this directly. E2, that is EMF induced in coil 2, is equal to minus M dI1 by dt. dI1 by dt is the rate of change of current in coil 1, and EMF induced in coil 2 is equal to capital M minus capital M. Minus, you will get to know it has got something to do with Lentz's law. We'll discuss when we are into the chapter of electromagnetic induction. Minus M dI1 by dt. Okay, so from here we can write it like M becomes minus EMF induced in coil 2 divided by dI1 by dt. Okay. Now EMF induced can be written as EMF is the work done in displacing a charge from one place to another. So this is work done per unit charge divided by di1. Di1 we can write down, that is the flow of current. It can be written as rate of flow of charge, and there is one dt in the denominator, so another t. So this becomes W by Q divided by Q by T square. Okay. W is work done, so it is the unit of energy. Energy is Newton meter. So we know how to find out that. Only thing is Q. Okay. Q, how to find out? Q is charge. So current is rate of flow of charge. So current, that is, I am writing directly as ampere, is equal to Q by T. I am writing here as capital T. Okay. For time, capital T. So Q becomes AT. Okay. So this thing we are going to follow in this out here. So W by Q, we are just writing M L square T minus 2 divided by, in place of Q we are writing S square T square, that is Q square. Okay. Divided by T square. So here you can see that this particular term is nothing but Q square. That has come from here. Okay, this has come down like this. So now if you further simplify this thing, how it takes the shape, M becomes equal to M L square T minus 2 and A minus 2. Okay, that is the dimensional formula for mutual inductance. Okay, so that is problem number 21. Then we'll go for the next one, that is problem number 22. Problem number 22, see, we are directly taking the problem. I have not told too much about the like the theory part of it. If you feel that I should tell the total theory part of it, then I can take a 1 hour total class of theory, should you wish to. If there is a requirement like this, please comment in the comment box that I want a complete 1 hour theory. Okay, I'll take it in the live session. Whenever you want, in a live session, totally, means I'm free to do that. Okay. Question number 22. Consider the efficiency of a Carnot engine given by eta, that is efficiency, and a big term is there. Here also one logarithmic term is there. Naturally, that will be dimensionless. In the denominator, that is sine theta. Sine theta is also the ratio of the sides of a triangle. So that is also dimensionless. Okay. Efficiency is dimensionless. Okay. So, and inside the terms are K, that is Boltzmann constant, theta is the angular displacement, T is the temperature, all these things are there. We have to find out which one is the incorrect options. Okay. So how to do that? So what is given here, since efficiency is dimensionless, so alpha beta here, this term, you know, it is visible, this term alpha beta is also dimensionless. So I can write here M0, L0, T0. Okay, that is also dimensionless. So that makes alpha is equal to 1 by beta. Okay, so that is alpha is not equal to beta. Now if you see the options, option D is given as alpha is same as that of beta. That is the wrong option. Okay. Okay. Next one is the expression of energy density. So U is energy density. So energy per unit volume is energy density. Okay, is equal to alpha by beta and sine of alpha x by kt. Now sine of something is dimensionless because that is the ratio of the length of a triangle. So it gets cancelled and it becomes dimensionless. Okay. What we need to find out? We have to find out the dimensions of beta. So the very similar problem we have already done in the past. So we'll just follow that. So sine alpha x by kt. So I can directly write this term to be dimensionless. That is why alpha x by kt, where k is the Boltzmann constant. So it is dimensionless. So this becomes m0, l0, t0. Okay, so from there we can find out that alpha L divided by, in place of K, that is Boltzmann constant, we can write M L square T minus 2 K minus 1, and there is another T, that is temperature. So here also I am writing Kelvin. Okay, is equal to 1. So that makes, what is the value of alpha we get from here? Alpha we get to be ML T minus 2. Okay, this is the value of alpha. We need to find out beta. So alpha by beta here, alpha by beta will have the same dimension of U. Okay, LHS and RHS, if you compare, alpha by beta will have the same dimension of U, which is dimension. No, that is not dimensionless, which is energy density. So energy per unit volume. So what is the dimension of energy? Energy is Newton meter. So energy per unit volume. So energy is Newton meter divided by meter cube. If you break it down into dimensions, what it turns out? So alpha by beta, that becomes, energy becomes M L square T minus 2 divided by L cube. L cube is for meter cube. Okay, that comes out. Now beta from here can be expressed as M L T minus 2 L cube on the other side divided by M L square T minus 2, that comes out to be M0 L square T0. Actually it is only L square, means M to the power 0 is 1, T to the power 0 is 1. So this is the value of beta. That is how we obtain the value of dimensions of beta. So that is problem number 23. It was, you can see in which year, in which shift this was asked in JEE mains. Okay, let us go to problem number 24. Problem number 24, what is given? Capital P is the momentum, capital A is area, capital T is time, are the fundamental quantities. So then the dimensional formula of coefficient of viscosity, that is eta. Okay, so how to write that? We can write here as F equal to eta A dV by dx. Okay, now eta, that is the viscosity, can be written as Pascal into second. Okay, Pascal into second, how it has come? Probably you can find out how it has come, because from here itself we can get that this is equal to F by A into, if it goes on the other side, this becomes dx by dv. So F by A is pressure, that is Pascal, and into dx divided by, so it's the length unit, so it is meter per second, dx by dt. So it goes on the top, so this becomes p into dt, that is why pascals into seconds. Okay, so this is actually, it has come like this. So I'm just skipping those things and writing directly eta equal to Pascal into second. Okay, now what? That is written as Pascal into seconds. Now we can write eta is equal to, since it has to be kept in terms of momentum, area and time, so we will also keep it in those terms. Okay, so eta becomes equal to momentum p to the power x, a to the power y, t to the power z is equal to Pascal into time. So Pascal is M L T minus 1 into that is Pascal, and into time, that is T. Okay, so and here P is momentum. Just one second. Here let us simplify it further down. Eta, this we can write, only Pascal second can be written as M1 L minus 1 T minus 1. Let me write down what is the value of momentum, that is P. P here, it is momentum. Let me write down momentum is equal to MLT minus 1. A is area, so it is L square. Okay, this if you are putting it, that becomes MLT minus 1 to the power X, L square to the power Y, and T to the power Z. That becomes M1 L minus 1 T minus 1. Okay, and this one, if you compare it on the LHS and RHS, this becomes X equal to 1, L to the power X plus 2Y equal to L to the power minus 1. So X plus 2Y equal to minus 1, and T to the power minus X plus Z equal to T to the power minus 1. So minus X plus Z equal to minus 1. So if you just solve it out, it becomes X equal to 1, Y equal to minus 1, Z equal to 0. So that makes it viscosity becomes P to the power 1, that is momentum to the power 1, area to the power minus 1, time to the power 0. Okay. It comes out like this. Fine. So this is how this problem is done. Next, we'll go to the next problem, that is problem number 26. 26, it is given that if force F, length L, time T are fundamental quantities. It is very similar to the earlier problem. I'll just write down the basic formulations. I hope you'll be able to do this. We have to derive what is the dimension of density. Okay, so dimension of density here very similar to the earlier one. So density is to be written in terms of F to the power A, L to the power B, and T to the power C. Okay, so density is kg per meter cube. Force, you know, Newton. Okay, to the power A, this is L to the power B, T to the power C. Okay, all these things are known to you, so you need to just compare the formulations, how it becomes very similar. So I'm not going very detail into this because we have already discussed similar problems. This becomes M L minus 3 T to the power 0, and on the other side M to the power A. Please work out the problem. Okay, problem mathematics is something where if you see and if you feel confident in the exam, you cannot make sure that you are in a position to do it. Okay, so you must also only work out the problems. The moment you work out more and more, the more and more you feel confident about. Okay, n to the power A, L to the power B plus A, and T to the power C minus 2A. You just compare the whatever the orders in the LHS and RHS, you'll find that A becomes equal to 1, B becomes equal to minus 4, and C becomes 2. Very similar to what we have already solved. That is why I have quickly solved it. Okay, please try it out by yourself. Okay. That's all for today. We'll continue from problem number 27 in my next episode. Okay, we'll continue for another 6 problems. Okay, please keep in mind that if you want the total theory of this chapter, I am ready to take a live class for this at your convenient time. Doesn't matter. You can write down in the comment should you wish to have a total 1 hour live class. Okay, where you can also interact with me at our convenient time. Okay. Thank you for watching. Thanks a lot.